Hello, Algebra. All right, guys, we got another doozy today. Let's see. Yeah, I think it's okay. We do. We have another doozy today. Chapter 13. It's a combination of chapters 11 with rationals and chapter 12, which had all the expressions and things like that. Not gonna lie, not gonna sugarcoat it. This is a tough one. Okay, today we are simplifying rational expressions. A rational expression is a ratio or fraction of polynomials, but the big thing is the denominator cannot equal 0. That's probably the biggest thing, the most important thing to keep in mind as we move forward, is we're going to be solving a lot where the expression cannot exist because it makes the denominator equal 0. Here's some examples. So here's the first one. So it does check out as a polynomial because they're many terms, right? We've got x's, numbers. Okay, so it is a polynomial, check. But no matter what we do, 5 cannot equal 0. Just doesn't. It never equals 0. So it is always true, this expression, no matter what the x value is, this value or this whole expression will be able to graph. It won't have any undefined things. It's not going to make your calculator freak out. This is good to go. This next one, however, is not. Let's say our x equals -2. Okay, so if we plug in -2 for both of our x values, we'd have -2, and then -2 plus 2 is 0. Well, you can't divide anything by 0. So therefore, we call this expression undefined when x equals -2. -2 in this case is an excluded value. And you would just see this expression, but you would see x cannot equal -2. You would see it like, let's see, let me write it. This is how you'd see it. So x over x plus 2 when x does not equal -2. That's how you would see it. I don't know why I'm writing in light blue. It just looks like the lines on the paper. Okay, moving forward. So like I said, we're going to have to determine excluded values, which, since these are polynomials, means we're going to have to solve for zeros of denominators. Now, you guys, you guys are basically professionals at it because this is what we did last chapter. And I could hear the choir of groans. Hopefully that made you guys laugh. Or otherwise, it's just going to make me laugh, and I'll be laughing at my own stupid jokes. Okay, here's an example. X minus 6 over x minus 9. Okay, so what we're going to do is we're going to set the denominator equal to 0. So x minus 9 equals to 0 and solve for x. So we add 9. So in this case, where x equals 9, this expression is undefined. That's the fancy word, undefined. So therefore, x cannot equal 9. That's it. This value makes this expression undefined, and therefore we can't do it. Cool, moving on. Here's another one. Polynomials. Yes. But all we need to do is solve for the zeros of the denominator. Okay. Well, this guy, let's see if we can factor. So I'm going to set it equal to 0. Can we factor it using the AC method? Well, 7 times 1 is 7, but -7 times -1 adds up to -8 and multiplies, so that's it. So our factors are -7 and -1. I just plug them right in because I don't have any I don't have any coefficient in front of my x squared, right? And then I'll set each of these individually equal to 0, solving for x, right? You guys remember that? That's what we did all last chapter. So in this case, x cannot equal 7 or 1. Okay, hope that's straightforward enough. Hope that kind of makes sense. Veronique, don't be sad. Don't be sad. Just grin and bear it. You guys can do this. It's not going to get any prettier, so best face it with a good attitude. Hey, and hey, remember? I said it was going to be tough, so at least I'm not lying, right? Okay. What is nice is there will be many times where we could reduce or simplify these rational expressions. Let's take this for example. 4c cubed divided by 8c. Are there any common terms? If there are, factor and cancel. Okay. These are our 2 steps, by the way, factoring and then canceling. We'll get to that in just a second. So 4c times c times c divided by 4 times 2 times c. Yeah, I could have done 2 times 2 times 2 times, right? I could have done that, but now I'm going to be canceling out a 4 from top and bottom and one of my c's from top and bottom, leaving me with 2 c's on top and a 2 on the bottom, or c squared divided by 2. What that looks like, let me just do that in pencil. So I'm going to cancel those out. Then that c times c is c squared, and then I'm left with 2 down on the bottom. Okay. There will be other times. This is a great note. And look, I emphasized only common factors can be canceled. Here's what I mean. Let's say we have x plus 2 divided by 2. Can I just divide out 2 from x and 2? No, I cannot, because that would look something like this, and x plus 2 divided by 2 does not equal x plus 1. Right, this is not the same as that, so no. There's not a 2 with our x term, right? Our x term is 1x technically. You can't divide 1x divided by 2. Then we'd have x over 2, which is what we have in the first place. So just leave it like that. Okay, moving forward. Don't groan. We can do this. Okay. So first step, like I said, is to factor completely. So first of all, we're going to factor this guy, the top, and then factor the bottom. And if you've memorized your patterns, you will know that on top we have x plus 2 times x plus 2. Sorry, I totally fudged that. That's a 2. X plus 2 times x plus 2. And then on the bottom, we're going to have x minus 2 divided by x plus 2. Then what we do is we cancel out common factors, and we're left with x plus 2 over x minus 2. Now, it just asked us to reduce, so this is the reduced form. Yes, you would say that when x does not equal positive 2, right, because that makes this 0. It's okay if the numerator is 0. That's fine, because 0 divided by anything is 0, but something divided by 0, you just can't do. That's where you guys get into infinity and alternate dimensions, and it just don't go there. Okay, last portion. Stick with me. It's confusing. It might be a little scary. So I drew my picture and then realized that I'd overlapped it, so we are going to do geometry type things. What I did was I traced a quarter, and we have a radius here in our circle, right? We don't know what the radius is, and then we have a square on the outside. And you will find questions like this. Write a rational expression. So we have a variable. We do. Our is our variable. Write a rational expression for the portion or proportion of the square that is shaded. So what's the ratio? What's the proportion of the square that's shaded? Don't just give me the circle. There's a proportion, there's a fraction, there's a ratio, there's a percentage that is shaded compared to what is not shaded. Here are the steps. Step 1. Expression for the area of circle divided by the area of square. So we need to find our formulas. On homework tonight, there's going to be a few. I think I just have 2 of them assigned to you guys, but there's going to be a few that just stick with me. Write the area of the circle, divide it by the area of the square, right? Or the area of the shaded divided by the area of the not shaded. So the area of the circle is pi r squared, and the area of the square is side squared. Now, wait a second. We don't actually know what our side is, but we know that if this is touching there and our radius is going to touch there, well, then the side of our square is the same as twice our radius. You could say our diameter, but we're going to keep the same variable. So the area of the square is 2 times the radius, right? 2 times the radius is going to be 1 length of the side. But for a square, it's the side times the side. So 2 times the radius squared. So we have the area of the circle, pi r squared, divided by 2r squared, which is step number 2. Write the expression. When I square 2, I get 4. When I square the r, I get r squared. So this is my expression. Write a rational expression for proportion that's shaded. This is it right there. But we can reduce. We can simplify. Step 3 is to cancel common factors. Well, our radius is the common factor, or rather our radius squared. So the ratio, the proportion that is shaded compared to what is not shaded is pi over 4. Okay, we're almost there. Step 4 is to complete division and then convert to a percentage. Once the percentage rounded to the nearest tenth. So pi divided by 4 is about 0.785. And when you convert that to, remember doing a percentage, you move it over twice. It's about 78.5%. Okay. I could see your faces just like, what? So this means that 78.5% of the square is shaded. So if this whole circle is shaded in, 78.5% of the square is shaded, or which is pi divided by 4. Okay. I hope this helps. I will, of course, be willing to answer questions, etc., etc. If that doesn't help, maybe seeing Kylo Ren in his little Imperial fighter go, meow, maybe that'll help. Maybe not. Otherwise, I love you guys, and I hope that you have a fantastic day. Bye.